All right, now we talk about ellipses. All right, an ellipse. Well, it's geometrically, it's this. You start with 2 points, F1 and F2, called the foci, plural focus. That's Latin for you. And we want to have all the points P, such the distance between these two adds to a constant. F1P plus F2P equals a constant. Same constant for this, and for this, and for this. Traditionally, one of the ways to draw an ellipse is to push 2 thumbtacks into a piece of paper, and I presume the desk underneath it, then take a loop of string, pull it taut around there, and put your pen at this corner of the loop of string, and then swirl around. That way, the distance from P to F1 plus P to F2 is a constant, and that's an ellipse. Now, all right, if we have an ellipse like this, with what's called a horizontal major axis. This from here to here is the major axis. This from here to here is the minor axis. Okay, and the foci are always aligned along the major axis. So if this ellipse goes through 0 by 0, and the foci are C by 0, negative C by 0, and here the endpoints of the major axis are at A by 0 and negative A by 0. And here the endpoints of the minor axis are 0 by b and 0 by negative b. Then the equation is x squared over y over a squared plus y squared over b squared equals 1, with the foci at plus and minus c by 0, where c is root of a squared minus b squared. That's if a is bigger than b. If a is less than b, then you swap things around, specifically these around. And okay, fine. This is what happens if b is bigger. That's still x squared over a squared plus y squared over b squared equals 1. But now c is, instead of root a squared minus b squared, it's root b squared minus a squared. So it's root of the bigger squared minus the lesser squared, square root. So that's for a vertical major axis. Now, let's assume it's a horizontal major axis and a is bigger than b, then we'll let c over a, that's called the eccentricity of the ellipse. It's a number between 0 and 1. If the eccentricity is 0, then you have a circle. If the eccentricity is 1, then basically you just have a line. So here's E is about 0 for a circle, about 0.8 if you stretch it out a bit, almost 1 for it really stretched out. So here's an example. Here's an equation. X squared over 36 plus y squared over 81 equals 1. Find the vertices, foci, eccentricity of the ellipse, and graph it. Okay, first we write 36 is 6 squared and 81 is 9 squared. X squared over 6 squared plus y squared over 9 squared equals 1. Okay, that means the vertices on the x-axis are plus or minus 6 by 0, and the vertices on the y-axis are 0 by plus or minus 9. All right, and then we take the bigger squared minus the lesser squared, square root. C is root of 9 squared minus 6 squared, that's root 45, 3 root 5. So those are the foci. At 0 plus or minus 3 root 5, its vertices are plus or minus 6 by 0, plus or minus 9 by 0. So it's looking something like this. The eccentricity is 3 root 5 divided by 9, which is about 0.745. So that has a eccentricity of about 74.5%. Now here we have 3x squared plus y squared equals 9. Ooh, this 9 is annoying, but we can solve that. We divide both sides by 9. 3x squared over 9 plus y squared over 9 equals 1. Now, if you cancel the 3 and the 9, you get a 3, which is root 3 squared. 9 is 3 squared. So the equation is x squared over root 3 squared plus y squared over root 3 squared equals 1. Okay, we can right away find the vertices. The vertices on the x-axis are plus or minus root 3 by 0. The vertices on the y-axis are plus or minus 0 by plus or minus 3. And we take the bigger squared minus the lesser squared. That will be 3 squared minus root 3 squared. That's root 9 minus 3. That's root 6. And since 3 is bigger than root 3, the foci are along the y-axis. So it's 0 by plus or minus root 6. So something like this. Plus or minus root 3, plus or minus root 3, about plus or minus 6. And the foci somewhere around here. And the eccentricity is root 6 divided by 3, about 0.81649. 81.6 roughly eccentricity. Now here we have an ellipse with some foci given and a couple of vertices given, okay, along the same axis. Now c squared equals a squared minus b squared. Okay, it's on the x-axis, so it's an a squared minus b squared. So therefore, it'll be 4 squared equals 5 squared minus b squared. So after rearranging a bit, b squared is 5 squared minus 4 squared is 25 minus 16 is 9. Take square roots and get b equals 3. Okay, there we go. This is all we need. On the x-axis, the vertices are plus and minus 5. On the y-axis, they're plus and minus 3. So x squared over 5 squared plus y squared over 3 squared equals 1. And that's the equation. Okay.